We're now ready to start Unit 1, and this is the first section. The I can statement is I can use formulas to solve for a specified. Let's write the word variable here, so variable. So we're going to be taking formulas and we're going to be solving for a specified variable. And just as kind of a warm-up, let's review some of the common formulas that we've dealt with before. These are ones that are really good to remember, so if you don't have these memorized, it might be a good idea to kind of lock these away right now. Let's talk about the circumference of a circle. Remember, the circumference of a circle is the distance outside the circle. It's kind of the fancy word for the perimeter of a circle. The formula for circumference is C equals, so I'm going to do a big capital C, and then it's 2 times pi times r. 2 times pi times the radius. Remember, the radius is the distance from the center to the edge of a circle. The diameter is all the way across from one side to the other, right through the center. So a diameter is 2 radiuses. This formula often gets confused with the next one, the area of a circle. The formula for the area of a circle, hopefully everybody knows that one. The area of a circle is pi and then r squared. So you can see how similar these two formulas are. They both have a 2, they both have a pi, and they both have an r. It's just a question of where that 2 goes. Remember, with the area of a circle, you're going to remember that that one has the square on it because area is always measured in square units. That's why the radius is squared there. So keep those straight. Volume of a rectangular prism, in other words, that's a fancy word for a box. The volume of a rectangular prism is going to be the length times the width times the height. Distance between 2 points, so we're talking distance formula here. So I'm going to write down d equals, and then it's a big square root, and you might remember this one. I'm going to do a set of parentheses. I'm going to do x2 minus x1, and then we say quantity squared plus y2 minus y1 quantity squared. And that's kind of an adjustment on the Pythagorean theorem. That's how we develop that. You'll probably see that again later this year. We'll take a look at the last warm-up part. It says the slope between 2 points. Hopefully everybody's got that one memorized because that one is used all the time. It's the rise over the run if we're just talking about a graph, but here we're talking about the slope between 2 points. So this is going to be the difference in the y's. So this is y2 minus y1 over x2 minus x1. So the y's are on the top and the x's are on the bottom because the y's go up and down, that's like the rise, and the run, right and left, that's like the x-axis. Okay, now let's talk a little bit about why we use letters in algebra. We use letters in algebra because they're just really convenient symbols. Convenient. They're convenient symbols. So we could use lots of different symbols if we wanted to, but everybody knows the alphabet very well, so those are just a convenient choice for symbols. And what those letters allow us to do, what those variables allow us to do, is they allow us to represent lots of different lots of different situations with a single mathematical expression. And one of the most useful types of expressions that can save us a lot of time and a lot of effort, we always like it when we can save lots of time and effort, is a formula. So let's write the word formula here, and then we'll talk really quickly about this. We're going to say formulas a lot. The proper plural of formula is formulae. This is how you spell it. But that just sounds a little kind of hoity-toity and a little too non-layman type terms. So we're going to call them formulas. So formulas often involve variables and numbers. So depending on the situation, it might be really good to have one variable all by itself as opposed to another one. Maybe in this case, we want the r by itself rather than the a by itself. Now, the word for all by itself, you recall, is isolate. So we use the word isolate a lot. So what we're going to be doing is we're going to be isolating a particular variable. And in order to do this, we're going to use our equation solving skills. And our equation solving skills involve a lot of inverse operations. So let's write the word inverse right there. So this is going to be very similar to when we were solving equations. So for number 1, it says, solve each formula for the indicated variable. This means we'll treat everything other than the indicated variable as a constant. Let's write the word constant right here. We just treat it as if it were just a plain old number. All right, so let's take a look at example 1a here. It says t plus m equals r. Now I have no idea what this formula stands for. I mean, it may just be nonsense, but the point is it's a formula. Right now, r is all by itself. R is isolated, but what they're telling us right here is they want us to solve this for t. They want us to isolate t. So let's go ahead and isolate t. We want to get this t all by itself. Well, on that side with the t is a plus m, so we're going to get rid of the plus m. And how do we do that? We're going to subtract m from both sides. Now, the the capitalization of a letter in a formula is kind of a big deal. So if it's written with caps to begin with, you want to keep it capitalized. If it's not, you want to keep it lowercase and so forth. So on this side, the m and the minus m, they cancel each other out. They make a 0. So all I've got over here is just a t. So I've got t equals, and then right here I've got an r minus an m. Now those are not like terms, so really the only thing that I can do is just write r minus m, and I'm going to circle that and we're done. So that's really it. So the next one right here, we're going to take a look at this one. This is the formula for the area of a parallelogram, or a rectangle if you want to think of it that way. So the formula for the area is base times height, and we want to solve this for height. We want to get the h all by itself. Well, in between the b and the h is implied multiplication, so let's get rid of that by dividing by b. So we'll divide both sides by b. Those are going to cancel off. B divided by b is a 1. So we end up with h on this side, and we end up with capital A over lowercase b on this side, and there's our answer. Now there's an asterisk on this one. We're going to come back to that in just a second, but we have solved this for the indicated variable. We solved it for h. Now in this one we're going to get x by itself. So here's the x term right here. So let's first isolate the x term. Let's move that 4y to the other side. There's no sign in front of it right now, so that's a plus or a positive 4y. So we're going to subtract 4y here and subtract 4y here. Those of course are going to cancel to be a 0. We get negative 3x equals. Now, on this, I suppose you could write 5 minus 4y, or you could write negative 4y plus 5. It really doesn't make any difference as long as you're keeping things with the correct sign in front of them. I'm going to go ahead in this particular case, I'm going to go ahead and write negative 4y plus 5. Wouldn't be wrong if I wrote it the other way as 5 minus 4y. Then I'm going to get rid of this. I'm going to get rid of the negative 3 in front there. Of course, that's multiplying by negative 3, so we're going to divide by negative 3. I'm going to cancel those off right here, and here's what I get. I get x equals, and then let's just write it down this way. Let's write negative 4y plus 5 divided by negative 3. Now, one of the cool things about working with formulas is there's really not a whole lot of simplifying that can be done most of the time. So I'm going to go ahead and circle this right here, but I do want to point one other thing out, and that's in this box here. There are 3 ways to write a negative fraction. What are they? Well, one way to write a negative fraction, so I'm going to write negative a over b. I'm going to write the negative on the top. Well, if I wanted to, I could take that and I could slide the negative out front, so put it as a negative a over b. And the last way I could do this is I could do a over negative b. Now you'll remember from past years, of course, we can't do this. You can't do, we can't do negative a over negative b. And the reason for that is those would cancel off, and then that would just be a over b, which is not what we started out with. Okay, so that's not okay. So there are 3 ways, 3 places you can put that negative. You can either put it out on the top, out front, or on the bottom. Now, generally speaking, the preferred place to put it is probably on the top or out front. This is probably the least favorable place to do it. So when you see a problem like this, occasionally something will happen where you'll look at it and say, hey, I got this, but then you'll look at your neighbor or the teacher or the back of the book or a solution guide or something like that, and they got this. They got 4y minus 5 over 3. Now here's what happened on this. What they did is they did a little trick. They said, look, if I've got a negative on the top and on the bottom, let's take this negative right here. We really don't like negatives on the bottom, and let's slide it up here. So that leaves a 3 on the bottom and a negative 4y plus 5 up here. And then they just distribute through, and of course a negative times a negative is a positive, and a negative times a positive is a negative. So the nice thing about this one right here, so I'm going to change something on this. I'm going to circle this. So I'm going to write x equals. I'm going to circle this one right here, and I'm going to put a dotted line around the other one. Now the one that with the dot around it is not wrong. It's perfectly okay. It's just that this one looks a little bit better. We generally like it if the denominators are as simple as possible. And if you've got a negative in the denominator, that's just kind of a hassle to deal with. Okay? So this is probably the best answer. This is totally okay. There's no problem if you leave it like that. Now let's come back here and deal with this one right here. Deal with that asterisk. We also need to make sure that any variables that end up in the denominator are not 0. So you'll notice that this one doesn't have any division. This one has division, but we're dividing by a 3, and we know that's totally okay. This is dividing by a variable, and we're not sure what b is. They didn't tell us what b was. So we want to make sure that that's not 0, because remember, dividing by 0 is not defined. So I'm just going to write division by 0 is not defined. We don't get an answer for that. In fact, if you were to type something in your calculator like 7 divided by 0, it would tell you that there's an error with that. But this formula is about the area of a parallelogram, and you wouldn't have a parallelogram if you didn't have a base. So we're not in danger of dividing by 0. So let's take a look at a couple of these guys right here. And just a reminder here, I think I said this already, in some ways it's actually a little bit easier working with formulas and solving formulas rather than solving equations because there's really nothing to simplify. We have fewer like terms. All we're doing is just moving things around. So we're going to solve each one of these for the indicated variable. Notice that it says isolate the indicated variable. So in this problem right here, volume equals length times width times height, we're going to solve that for W. We're going to get the width by itself. So you'll notice that this is all multiplication. We need to get rid of timesing by L and timesing by H. So we're going to divide this side by L times H, divide this side by LH, and the L's are going to cancel to be a 1, the H's are going to cancel to be a 1, so this is what we end up with. We end up with W on this side, and then we end up with a capital V and then an L times H. And this right here would be the answer. Again, if you're one of those people who really likes it to have the variable that you solved for on the left-hand side, if you want to write W equals V over L times H, that's totally okay. Either one of those would be fine. We're actually going to talk about that type of property here later on in this unit. All right, let's take a look at the next one. We've got this formula right here. Looks like a bit of a mess here. All we want to do is we want to get f by itself. There are a couple different things that we could do here. I'm going to do this in what I think is the easiest method. We could also get rid of the fractions in this problem. We could get rid of that 2 right from the get-go, so we don't have to work with any fractions. But on this one, I'm just going to leave that right there. I'm going to get rid of the 15 by subtracting 15. So we're going to have d minus 15 on this side. Then we've got 1/2 f. We've almost got the f by itself. You'll notice that it's being multiplied by 1/2. There's a coefficient of 1/2. Remember, if we're solving an equation, we want to get rid of a fraction in front of the variable. We're going to multiply by the reciprocal. So we're going to multiply by 2 over 1. Now on this side, because there's already a fraction, I'm going to leave that 2 over 1. It would be a little bit silly to write a 2 over 1 here because none of these are fractions. So I'm just going to go ahead and cancel that off. I'm going to take care of the little OCD in me right here. We're just going to go ahead and put the f on this side, and we're going to write 2 times d, which is 2d, minus 30, and we're going to go ahead and circle that, and we're going to say that's the answer. Okay, so we're all set on that one. We'll take a look at this next one and then cruise through a couple more. We want to solve this for h. Again, notice that we're doing a bunch of multiplication here. You can do this all in one step if you would like to. I'm going to do this in 2 steps, so here's what I'm going to do. This fraction out in front here, this pi thirds, I'm going to get rid of that by multiplying both sides by 3 over pi. So we'll multiply by 3 over pi. The 3's will cancel, the pi's will cancel. So here's what I've got. I've got a 3v over pi. And notice how I just kind of slid those numerators together, multiplied those together, put them over one horizontal fraction bar. Then we've got an r squared times an h. The only thing I have left to get rid of is that multiplying by r squared, so I'm going to divide by r squared. Now when I divide by r squared, this is another good way to think about this. I'm going to slide this over and I'm going to think of this as multiplying by 1 over r squared. Basically what I'm doing is I'm putting an r squared on the bottom. So if I put an r squared on the bottom on this side so I can divide by r squared, I'm going to have to do the same thing over here. Those are going to cancel, and again here I get this 3v on the top, pi r squared on the bottom, and that's what h is equal to. Again, totally okay leaving it like this. If you wanted to write it in the other format with the h on this side, 3 and then capital V, don't forget that that was written as a capital to begin with, and then over r squared. Either one of those is totally fine. Okay, let's take a look at this next one. These look like they're a little bit uglier. We've got some similarities between the two of these. In fact, you'll notice that this formula is the same as that formula. I'm hoping you recognize that. This is the formula for the area of a trapezoid. And on this one it says it wants us to get h by itself. We want to solve for h. And on this one we want to solve for b1. So these are going to be done completely differently. So on this one, here's what I'm going to do. I'm going to multiply both sides by 2. That's going to cancel here, so I get a 2 and a capital A, and then I've got an h and a b1 plus a b2. Notice that that's in parentheses, so those are grouped together. That's one quantity right there. And then we want to get rid of that timesing by b1 plus b2, so we're just going to divide by b1 plus b2, divide this side by b1 plus b2. Let's go here. And that entire quantity is going to cancel with that entire quantity. So h is going to be equal to 2a over b1 plus b2. You can leave the parentheses on there if you want, or leave them off. It doesn't matter, because remember that horizontal bar is a grouping symbol in math. The top is a group, the bottom's a group, and we'd have to figure out each one separately and then carry out the division. Okay, let's take a look at this next one. Now on this one we want to get b1 by itself. So b1 is inside the parentheses, so this is going to be a little bit more difficult. So here's what I'm going to do. I'm going to think of this right here as a fraction in front of some quantity that I want to isolate. And remember, to get rid of multiplying by a fraction, we're going to multiply by the reciprocal. So we're going to do 2 over h here, 2 over h here. So here's what I've got, 2 capital A over h. And then on this side, remember, these canceled, so I get b1 plus b2. And then I just want to get b1 all by itself. So I want to take the b2 and I want to move it to the other side. So that means I want to subtract. So I'm going to subtract b2 here and subtract b2 here. Now this gets to be a bit of a mess, because if you take a look at this, we're in good shape over here. We've got this b1 all by itself. But on this side, here's what I've got. I'm supposed to take 2a over h, and I'm going to subtract b2. Well, remember what I said before. There are a lot of times where this is actually easier than solving an equation, because there's really nothing that I can do with this. There are no like terms, there's nothing common here or anything like that. So I actually get to leave this like this. And I am going to leave this with the b1 written on the right side here. Totally okay. If you want to go ahead and flip-flop that, that's fine with me. There is one thing that you might see down the road. They may get a common denominator or something like that. I'm not worried about that for right now, so we're just going to leave it like that. Now, I've got one last example here to look at, and it's f star. And this star is here to remind us this is a weird-looking problem. I showed this to a math class a couple of years ago, and they called this voodoo math. They got it, and they did pretty well with this stuff, but they just thought it was pretty wild and freaky. So here's what we're going to do. What we're going to do is we're going to solve for x. We're going to isolate the x. Well, this circle with the crosshairs through it, that's with the x, that's multiplication. So there's the variable term, so we want to get rid of the triangle. So I'm going to subtract the triangle from both sides. So triangle minus triangle, that would be 0. So I have circle with crosshairs through it times x equals, and then I've got a box with a dot in it minus a triangle. Those are not like terms. They're nothing close geometrically. So we're just going to write this down over here. And then I need to get rid of timesing by the circle with a crosshair in it. So I'm going to divide both sides by circle with a crosshair in it. So circle with a crosshair in it here. Those are going to cancel, and here's what we end up with. It said isolate the x, solve this formula for x, and here's what we get. We get box with a dot in it minus a triangle over circle with crosshair. And that right there is the answer. And my question for you is, see why we use letters? It's way easier to talk about A's and B's and C's and V's and W's and H's and stuff like that than it is to talk about circle with crosshair, triangle, square with a dot in it, and stuff like that. Now, this problem right here, if you'll notice, is very, very similar to one that we did already. We did a problem very similar to it, this one right here. So what we were doing is we were moving something over, a term over by subtracting, and then we got rid of multiplying in front. So example 1C is very, very similar to example 2F, and it gives us a good indication to why we use letters rather than some other weird symbol. They're just nice, convenient choices. Now, I do have a quick thought experiment, just something for you to think about because it may come in handy on the assignment or down the road. If you were given this rectangle right here, could you express the area and could you express the perimeter? Well, I'm going to write another picture of what this looks like, and let's come up with, we know that one's 4, let's come up with an expression that would represent how long the length or the base is here. Well, this is x and this is 5. We don't know what that is, but we do know that if you wanted to know how far it was from here to here, you'd go to x and then you'd add another 5. So this is x plus 5, and that entire quantity represents the base or the length there. So the area on this one would be 4 times x plus 5, because it would be base times height. And the perimeter we would have to take, well, if this is 4, this one over here is 4, and if that's x plus 5, then this up here is x plus 5. So one way we could do this is say, look, I've got 2 4s, so I'm going to do 2 times 4, and then I've got 2 of these, whatever this is right here, this x plus 5. Whatever that represents, I know I've got 2 of those. So this is a way that you could express the area, and this is a way that you could express the perimeter. All right, good luck with the assignment.